In my sample app so far, I'm loading up images in the background as they're required by the list. This allows the data to appear almost instantly, but then images appear whenever they're available. But as I described, my current strategy is going to run into trouble if I have too many bitmaps to store in memory. And in memory-constrained devices, this is definitely sometimes a concern. So a more sophisticated approach is to cache the bitmaps in something called an LRU cache. LRU stands for Least Recently Used, and it's a caching strategy where you set a certain amount of memory that's available for caching, and then add items to the cache, but if you run out of memory, the cache can discard the least recently used items. As long as all the images fit into memory, there won't be any problem, but if the cache needs to discard something, you'll be able to elegantly reacquire it when you need it. So I'm going to work in this version of the project, which is named imagecache, and specifically, I'll work in the flower adapter class. I'll start at the top of the class where I'll declare a new private field. It'll be an instance of a class called LRU cache. There are two versions of the class. If you're working on an app that's only going to work in Android 3 and later, you can use the version in Android.util. But if you're trying to target older versions of Android, use the version from the support library. I'll use the version from Android.util. When you declare an LRU cache, there are two generic declarations. These will be for the key and the value types. An LRU cache is essentially a map. Each item in the map has a key and a value, and the key can be any data type, and the value can be any data type. For my cache, I'll set the key type as integer and the value type as bitmap. And I'll name my new field imagecache. Now, I want the cache to persist for the lifetime of the adapter, and so I'm going to initialize it when the flower adapter is constructed. I'll add code here after the existing code in the constructor method. There's no specific amount of memory that you're supposed to assign, and the amount of available memory is going to differ from one device to the next. So I'm going to use an equation that comes from the Android documentation. I'll create a final integer that I'll name max memory, and I'll calculate its value by calling runtime.getRuntime.maxMemory. And then I'll divide that value by 1024. Now, what I really want out of that is an integer, so I'll wrap all that in a set of parentheses, and I'll cast the result as an int. And that's the total amount of memory that's currently available. Now, I'll calculate my cache size with final int cache size, and I'll calculate it by dividing the amount of memory by 8. Essentially, I'm saying use 1/8 of whatever's available. Again, your mileage might vary. If you know for sure that your app is running on devices that have a lot of memory available, you can adjust the equation. Now I'm ready to create the image cache. I'll instantiate it with imagecache equals new LRU cache, and I'll pass in my new cache size value. And now I have a place where I can put bitmaps. Each bitmap will be indexed by an integer value, and that integer will be the product ID of the flower that the bitmap is associated with. So now I need to modify some code. Down here in the getView method, I'm using this logic to determine whether I have a bitmap available. And currently I'm storing it in the flower object, which means that I'm storing all the bitmaps no matter what. I'm going to change this so that I'm looking in the cache. First, before the condition, I'll create a reference to the bitmap. I'll create a new bitmap variable that I'll call bitmap, and I'll try to retrieve it from the cache with imagecache.get. I'm asked for an integer value, and I'll provide it with flower.getProductID. I'm saying, give me the bitmap that's associated with the product ID of the current product, or flower. Now here's how the LRU cache will respond to the request. If there's a bitmap object in the cache, that's associated with that integer, it'll return it. And if it's not in the cache, it'll return null. So now my condition is simply if bitmap doesn't equal null. I'm no longer looking in the flower object, I'm looking in the image cache. The rest of this logic, though, still works. If the bitmap is available, I'll display it. But if it isn't available, I'll create my asynchronous task and get it from the web. Now, I'll also change how I'm adding the image or the bitmap to the cache. I'll clean up that little bit of code. Then I'll scroll all the way down to the bottom of my class. This line of code is currently saving the bitmap in the flower object that's in the persistent list. I'll comment that line of code out. And then instead, I'll add the bitmap to the image cache. I'll call imagecache.put. For the integer key, I'll use the expression result.flower.getProductID. Remember, the flower object was passed to this method as a member of the flower and view class. And then I'll pass in the bitmap, which is currently also a member of that container, with result.bitmap. And now I'm using my LRU cache object to save my bitmaps in memory. And again, if my device starts running low on memory, the cache object can intelligently discard whatever I haven't used most recently. I'll save and run the app. The behavior of the app is exactly the same as before. When I click Get Data, I instantly see the text, but then the images load one at a time. And as I scroll up and down, I see the images load on request. When I scroll back up again, though, they're still available. If I run low on memory, though, I might see images start to reload, and that's fine. That's better than the alternative, which is crashing the app or otherwise affecting the device. So, if you need to save a lot of images in memory, it's a smart idea to use a caching strategy like this. Let the cache do the work for you, looking at the amount of memory that's available and deciding what to keep in memory and what to discard. As with everything I've shown in this course, all of this code will only work in an app that's constrained by orientation, that is, that stays portrait. If the user changes the orientation or hits another major configuration change, that can discard a lot of this information from memory and you'd have to start over. But those are issues that you run into in all apps where the orientation can change. When you're talking about working with HTTP requests, the ability to get the data as XML or JSON and the ability to retrieve associated binary content are all available here between HTTP URL connection, the LRU cache class, and the other tools that I've shown so far.